Hi guys, we're back at it again. Chapter 4, Section 7, Multiplying Decimals. Decimal times a decimal. As you can see here in your notes, you have some notes to write down, some steps to help you to solve these problems and make you successful with our multiplying decimal venture. As you can see, step 1 says to forget about the decimal. Pretend it's not even there. It doesn't even exist. Pretend all you're working with is a whole number. Step 2 says I would like you to multiply and solve this problem using standard algorithm. Just like you would solve any other ordinary problem, solve this problem. After you've solved the problem comes step 3, where I want you to count the number of digits in the problem that are behind the decimal. That number that you counted has to be replaced in your product, which is step 4. This many digits should be behind the decimal in the product. And our last step there, step 5, ta-da! You're done. That is your final product. These are the steps we're going to be using to solve a few practice problems and see how we do with this concept. As always, be thinking to yourself, where do I fall on my learning scale with this target, this multiplying decimals target? Keep in mind, I will be asking at the end how you feel about this. A 4, a 3, a 2, a 1. Let's get started, shall we? Alright, ladies and gentlemen, here's my first problem. 4 3/10 times 2 7/10. Going through my steps, step by step. Number 1 says to forget about the decimals. So we're going to pretend they're not even there. We're going to imagine this as being 43 times 27. Now, if you think of this as 43 times 27, then this takes us all the way back to chapter 1. And we can easily solve this problem if it is 43 times 27. So on your paper now, I would like you to solve the problem 43 times 27. To solve this problem, I'm going to say in my brain, 3 times 7 is 21. 4 times 7 is 28. Plus the 2 that I carried is 30. I'm going to then give myself a magic 0 with my belly button in the middle. Cross out my 2 so I know that I used it. Swing back. 2 times 3 gives me a product of 6. 4 times 2 gives me a product of 8. Once I have done that, now I can add up these two numbers to give me my product. So as of right now, my product sits at 1,161. This takes me down to step 3. I'm going to go back to my original problem, now reimagining that my decimals are in place, and I'm going to count how many digits are after each of my decimals. So I see in my 4 3/10 that I have exactly 1 digit after my decimal. And then I see in my 2 7/10 that I have another digit after my decimal. That gives me a total of 2 digits after my decimals. So in my final product, I'm going to have to make sure that my decimal lives in a spot where there are 2 digits also behind the decimal. That would be step 4. After I place that decimal in its new home, where it belongs, I'm on to step 5. Ta-da! I'm finished. My final product is 11 61/100. So let's try another problem. So here's the problem that I'm going to solve. 9 27/100 times 4 2/10. Take a look at the speech bubble down at the bottom. My speech bubble tells me, decimals do not have to line up when multiplying. My decimals only have to line up when I'm adding or subtracting the decimals, not when I am multiplying, because we're going to pretend like they don't even exist, so who cares where they are. So as I said previously, step 1 is to forget about my decimals. I'm going to pretend like this is chapter 1, and I'm going to multiply 927 times 42, which is step 2. Let's go and solve that problem right now. 7 times 2 is 14. 2 times 2 is 4. Remembering to add in the one that I carried is 5. 9 times 2 is 18. Magic 0. Cross out that 1 so I know that I used it. Swing back and let's multiply with our 4. 4 times 7 is 28. 4 times 2 gives me a product of 8, plus the 2 that I carry gives me a product of 10. 4 times 9 gives me a product of 36, plus the 1 that I carry gives me a product of 37. Now I'm going to add up these numbers. $38,934. Now, as you may recall, my next step is to count the number of digits that live behind the decimals in my original problem. So I'm going to do that now. I'm going to count them up, Buttercup. 1, 2, 3. I have 3 digits behind the decimals in my original problem. So I'm going to make sure that my product mimics this and also has 1, 2, 3 decimals behind it, giving me a final product of 38 and 934 thousandths. Now we've come to the time in our show where I have a problem for you that I would like for you to pause the tape and to solve it on your own to see if you can do so successfully without my assistance. Once you've solved the problem on your own, resume playing the tape so you may check your work and see if you solved the problem successfully. Please do this. Meow. So I'm going to think in my brain. This is no longer 53 and 5 tenths times 1900ths. It is now 535 times 19. And I'm going to solve this problem. I'm going to do it in my head so it goes faster. Follow along. One, two, three. 1, 2, 3. So my final product is 10 and 165 thousandths. Now going back to our learning scale. If you were able to solve this problem successfully without watching the video, you solved it and then you checked it with my answer and it came up correct, I would give yourself a 3 on our learning scale. If for some reason we had a fault when we solved this problem independently, then be honest with yourself. Know that you need some extra practice on this. There's nothing wrong with needing extra practice. The more we practice, the better we get. Honestly, give yourself a 2 or a 1, depending on where you sit on that scale. Always be thinking about your learning skill and how you can achieve the next level. If you have any questions on how to perform and answer these style questions, please feel free to ask me tomorrow in class. We'll be working on more practice problems to enhance your learning of this skill.